Welcome TechBrothersIT. In this video, we are going to learn how to read data from different CSV files and then join the data from those CSV files and then create a delta table in a Lake database on every time we execute our notebook. So what we are going to do, what I want to demonstrate from here, let's say you have these files sitting here, and in this case they are sitting here in the input folder. Now you have customer file here, and then you have order file. Let me actually take you through the Synapse because I have the link service there, so I can show you from here. That's the container, and this is the input folder, and then you have a customer file here, and let me preview, and you have order customer ID, first name, last name, and then you have order CSV, and here you have order ID, customer ID, order data. So I would like to join on customer ID from both files, from customer file and order file, and then what I would like to do, I would like to load the data into the table. And this is the database called Lake DB demo, and I would like to create a table something like that. So it will be your customer order table underscore date, year, month, day, and time. So that's what I would like to create. So every time maybe think about scenario, every day we get this file replaced here, or every hour, and then what we do, we run the notebook that read the data from customer table and order table and join the data, and then create a new staging table. You can call it whatever you want to call, a staging table or whatever. It is delta table I'm creating, or you want to create Parquet or CSV, you can create that too. And then maybe later on from there you will use that table to create maybe dimension tables or fact tables or whatever. So it can be a lot of scenarios, but our goal is to read these files, load into the table by using notebook, and then also use that notebook in the Synapse pipeline and schedule. So that's what our goal is. So you will learn the entire process. So here is my notebook that I have created. So I went to the develop here, and then I created a new notebook here, and here is my notebook. And the very first step what I'm doing here, I'm saying from importing datetime, so I can use this datetime later on in the notebook where I need to create some use functions related to the datetime. So here's my path for the customer file, and this is the variable I declare here, customer underscore path, and then I have this path here. If you're curious how I got this path, I went to the link here, and here's my link service for the Azure Data Lake storage too. So I went to that container where my file is, and then here is my file. I right click here and then go to properties, and I got this path from here. So that's your Azure path right there. So you can copy from there and then use it. Now I will go back to the notebook here, and then I define another variable called orders path, and this is the path to my orders file. The same way I went to the container here and just right click on the orders, and then went to the properties and saw the properties for this file, and this is my Azure blob path. Okay, great. Now we have right there, and then what we did in the next step, we want to read these CSV files. So here I'm creating a data frame and called df customers and spark.read, and that's what the function is used to read the file from this customer path. And I'm telling you, okay, header is true because this is my header. This file has the header, and then also this is .csv file. So this is going to read the CSV file with the header, and then from this path, and then save into this data frame. So data frame is the table-like structure in the Spark that has columns and the rows, and then we can read this data from the file and load into this data frame. So it's in the memory, and then we can join with the other data frames. Here I'm creating another data frame called df orders, and here I'm reading a df spark.read function is used to read this file, and this is the orders file, and the comment from the path is orders path, and it's also CSV file, and it has header too. Now once that's done, what I'm doing here, I'm casting so df customers, a new data frame I'm creating here, and this is my old data frame, df data frame customers with column. So I'm saying customer ID df customers customer ID cast as an integer. So I'm converting this customer ID to the integer type, and doing the same thing here, and right here df underscore orders, and then with column. So I'm just overwriting to the same data frame name, and then what I'm doing, I'm converting this customer ID to the integer as well. So I kept the data frame name same here. You could have created a new data frame here, say maybe 1 or 2, and then use it, but I overwrote the same data frame name by also converting the customer ID. Rest of the columns will come as is, Okay, now we have the data frame and the customer ID is converted to the integer as well. Here we are creating a new data frame called df join and we say df customer. So this is my data frame join with the second data frame df orders on customer ID. They both have the same column name. So you have the customer ID, how inner join, and this is going to create the df join. So the data from these both data frames will join on customer ID, and whatever the matching records are, they will be saved into the df join. Now once the data is saved in this, that's great. I would like to also create a table. Remember that with the timestamp. So if you get here, so I'm saying, hey, timestamp underscore str, that's my new variable here, and saying datetime dot now, taking the time as of now when it is running, then string time, and then the format I have defined it here. So year, month, day, hour, minutes. So and here I'm creating a variable called the table name, and then that's my database name, customer order underscore this time that I will be using it here. So that's how my table will be created every time I will execute my notebook. And then you will say print, and then we say creating table name. So this will tells you Lake db underscore demo customer order underscore whatever the date time at the time of execution. Now once this table name is ready, then we can do one thing. We have a df join that has our data right format. So we are saying, hey, as a delta format, save this df join data frame to the this path, save as table. So table name, whatever the table name we have given. So our table name has a database name, table name with timestamp. So this df join data will be written to the table, and the table type will be delta. Okay, great. So now if I execute this one, it will just run fine here. If I want to go ahead and execute one more time here, it's going to go ahead and execute. Now you can also publish this one, and then let's see if we make a small change or something like that. So we can just publish here. Okay. So it's going to run. I'm going to go to the database here, and then go to workspace here, and then go to Lake DB demo here, refresh, and then it's going to create a new table for us. So you see that this new table is created, and now I can right click here and say new SQL script, select top 100 rows, and then I can execute. This is using my serverless SQL pool, and I can use the serverless SQL pool to get the data from my delta tables in the Lake database. So that's what I'm doing it here to confirm, and there is data. Now that works great, but think about the scenario if I have to run this every time, maybe through the through the night. Every day they place these files maybe in the 3 times 4 times in the day, and I want to run every 4 hours, and then I want to execute. Then how I will do that? So in this case I will be going to the integrate here, then I will be going to the pipelines are here, and I'm going to create a new pipeline. So go to new pipeline, and here we call this one PL load delta table. Okay, so that will work. And now what we need to do here, we need to get Synapse, and here is my notebook. And if you remember that all the notebooks are saved right here under develop, and this is one of the notebook is called Synapse join customer orders underscore fixed. So I'm going to click right here in the notebook and go to settings here, and then select the notebook. So this is the notebook I need to run. And then it is asking you, hey, select your Spark pool. I'm going to go select my Spark pool. I have TechBro pool that I have created. If you want to take a look on your pools here, you can always go to manage here, and then Apache Spark pools, and you can take a look from here. This is the 4 vCores, 32 GB, 3 to 10 nodes. See Spark pool. So I have created that one. If you want to look on more properties and scale down or scale up and all that, you can take a look on this one. So for now I'm fine. It is a 3 nodes for now. When it needs more, it will go to the 10 nodes, and each node has 4 cores, vCores, and 32 GB RAM. Now if I go back here in the integration, and here is my notebook, I click right here, and you have settings, and in the setting I have selected the notebook. That's good. And what is next? I'm going to go ahead and select the pool, and it's called executor size. So if I can go here, I can now give like maybe 4 week cores, or I can 8 week cores. I can give as much as I want. In my case, I'm going to go with the just 4 week cores for now. That's fine. But depending upon your case, and you have driver nodes, and you have if you remember, there are driver nodes and there is a compute nodes. You can also define the driver node and compute nodes. So that's also you want to do that. The value of driver node should be the same as the value of the executor. So that is also true. So you have to have a same configuration here. So I'm going to go with the small here and leave this everything as is. Now, as we have done setting, we have told which notebook to use, which Spark pool to use, and what is the executor size. So in this case, I select a small 4 week cores and total 28 GB RAM, and that's it. You can have a min and max executors as well, and then we can also select the authentication if you are using a system authentication or user manager entity and all that. In my case, I'm going to just leave as is. My pipeline is right here, and then my notebook is also here in Synapse saved. So all good here. We have already published, and now what we are going to do here, we are going to execute this pipeline. This pipeline is running a notebook, and as you know that once we run it, we should see a table here come in, creating with the date time. And right now we have 3 tables already, but it should create a new table for us. So let's go ahead and say trigger now, and that should trigger it. Okay. So now it is running our pipeline. If I go back here to the monitoring, and if I will take a look on my Apache Spark application and refresh, then I should see that, oh, this is the application name, and then what it is status is queue submitting and all those. Now it should be coming up to the running. That looks fine. If I go to the pipeline run, then I should see my pipeline is also in the progress. So it's right there. So it's running right now. So once this is completed, what we should see a new table created right here. So I'm going to refresh and then take a look here, and we should see a table soon once the pipeline is completed. Our pipeline has completed, and you can see right here, if I click right here, it will tell you more details and tells you one notebook, and this is our notebook name here, and then tells you, okay, the executor size was small, and then we can close this. We can go on the output side and take a look. So it tells you the IP and ID of that, and then tells you the notebook names and all those kind of different more detail, like your Spark pool name, workspace name, and app ID and submitted and everything. So you have more information on that one. And once you want to see the final output here as well, you can click on there, and it will show you the your notebook, and it shows you the run ID, and it also shows you the Spark pool name. And if there is anything, like you have put the comment such as I have a print statement here, it showed me the print statement here as well. So that's good. So our table that it created is ending on 32146. So if I go right here and then check the Lake DB demo and refresh, then I should see this table right here. So see, and now I can go ahead and execute this and select top 100 rows. Let's execute, and I'm using serverless SQL pool here to query my Lake database table, and this is doable when we can use the serverless SQL pool to query our delta tables from the Lake database, and see the records are loaded into this table. So this is how you will create your notebook and then create the Synapse pipeline and run it. Now, one thing I did not show you, if your pipeline is created, and what you can do, you can also schedule it. You can go to add trigger here, then a new, and edit, and then here say new trigger, and then you can use schedule here. You can choose the start date. Let's say you want to start from a weekend or something like that. You can choose that, and also you can specify the time, and here is your time zones according to the time you would like to execute, and then you can tell like you want to execute every 15 minutes or hours or all that. It is right here. You can change, and then start trigger on creation. Then once you hit that, the next time when the time will reach on schedule, it's going to execute accordingly. So this is how you will create the schedule for your pipeline in the Synapse pipelines. So I thank you very much for watching this video, and I hope you learn how to create the notebook here that reads the CSV files right to the Lake database by using notebook, and how to create a Synapse pipeline to schedule it as well. I will see you guys in the next video.